especially from the Atlantic area, tropical Atlantic, and also from South America inland. So that means he will present a conference, a seminar about both freshwater and marine faunas from the last 23 million years. Because many people here are working on the same topics, and that's why we are so happy to have him today. So, Orangel, por favor.
Okay. First, thanks so much for the invitations, especially for the Lab X committee and Professor Pierre-Antoine. Today we talk about the new gene, marine and freshwater fish fauna from tropical America. We need to start asking about the modern fish fauna, especially from the Amazon River or Amazon fluvial system. It's so easy to recognize the freshwater Amazon fauna if you visit the fish market at the Belém city, Belém Fish Market in the Pará state at the north of Brazil. Especially the abundance and diversity of siluriform like pimelodids, doradids, loricarids, or also the well-known piranhas, cachamas, pacus, serrasalmids. Also, in this area, because it's very close to the Amazon Delta, in the fish market, you can observe, you can find also estuarine fishes, brackish, like marine catfish, like arid family, or drum and croaker that is very common in this estuarine area. But in the middle of the Amazon, in the fish markets or in the Manaus city, is planted in high diversity of fishes from the Amazon system, especially also siluriforms, pimelodids, doradids, loricarids, and also serrasalmids like cachama, pacus, piranhas, and the lungfish arapaima, pirarucu. To understand this high diversity with almost 5,000 species or freshwater species in the Amazon hydrographic system, included some freshwater mammals like dolphin or sirenids, manatee, and reptile like crocodiles or turtles. We asked how this fish assembly reach this high diversity at the world, okay, with around 5,000 of species. And we need to look the past to understand the evolutionary trend, the origination, extinction, and turnover under the area and the assemblage of this fauna. We understand the context about around the geochronological sequence. We study separated some marine and estuarine or brackish area and freshwater area. For example, we study at basin and units from the Pacific coast, from Ecuador, Panama, from the Caribbean coasts, from Colombia, Venezuela, Trinidad, Dominican Republic, Jamaica, and the Atlantic Gulf of Brazil. And in the Western Amazon, also from Brazil, Colombia, Peru, and north of Argentina. This picture is very interesting because our research included more than 51 units or formations. But all this formation is like a mosaic. It's not a continuous geochronological section, except from one part of Venezuela, especially in the Urumaco Trench. But this scarce distribution of the different units follow the tectonic and the geographic and geological dynamics in all this area that we discussed today. Of course, our interest today to show you is from the early Miocene to the Pleistocene records, both marine and freshwater. Associated, of course, this picture with a geochronological sequence with some climatic events, okay? Oceanographic, hydrographic, for example, the Oligocene-Miocene border during the ME1 glaciation, the Amazon onset eastward, the middle Miocene climatic optimus, the middle to late Miocene MI4 glaciation, the onset of the Amazon River around 10 million years here. Okay. The onsets of the Orinoco and Essequibo River around 5.5 million years, and the Panamanian Isthmus of lifts around 3.7, 3.5 million years. Of course, during this geochronological sequence included the rise of the Andean Cordillera. To understand the fossil records in South America, diverse contribution from the Paleogene to the Pleistocene continue to work in this area, especially from the western part of South America. The question is, what happened with the middle or the central part of the western Amazon? Some units we know that has fossils, but is inaccessible. For example, around the Manaus city in the Amazon, because it's very hard to reach outcrop by the forest vegetation, the logistical problem to access all this area. For this reason, is the western part of the South America is the most investigated until now. I have some example of the probability to find fossil in our area. And we use and describe it like a triangle in South America. This picture is from the Tatacoa Desert in Colombia, between the central and eastern Cordillera. The age is middle to late Miocene and included La Victoria and Villavieja formations. Okay? Tatacoa Desert is planted in fossil fish fauna, but this fish fauna is associated with Proto-Amazon fauna. It's a typical fauna from the Amazon that living today, like this large Pimelodids, Brachyplatystoma guayanti. I show again to you a skull and fish bone remain from the Brachyplatystoma in the desert of the Tatacoa in Colombia. Other example is from the Solimões Formation in the western part of Brazil, near the Acre, Rio Branco city, Purus River, where we find again a large catfish or freshwater fish fauna assemblage, typical proto-Amazon fish fauna. This picture is an example of Fractocephalus emilioterops. It's a red-tailed pimelodid catfish that we talked ahead. Other desert area very important for understanding the proto-Amazon fauna distribution during the early middle to late Miocene is in Guajira Peninsula in Colombia. It's a South Caribbean. Today it is a desert area, totally desert area. And we find again remains of protofauna, proto-Amazon fauna, like a large pimelodid catfish. It's a Brachyplatystoma, also from Colombia, desert. The triangle continuity. And this triangle we can find in Venezuela in the northwestern part, the Urumaco Formation, very close to the line coast of the Caribbean, exactly 5 kilometers from the line coast. And we find in the desert, again, more siluriform species related with the proto-Amazon fauna. This picture is to illustrate the occurrence of doradids, very frequent in the fossil form, skull, postcranial element, etc. Okay, the best way to show the complexity of this proto-Amazonian fauna included a high diversity or paleodiversity of vertebrates, including terrestrial mammals, big ones, freshwater mammals, reptile, turtle, and of course, fish fauna. The same that you can see today, families, some genus in the fish market in the Manaus city or in Belen city. It's included, of course, Fractocephalus. It's a pirarara, pimelodid catfish. Okay? This is from the Urumaco Formation. This is the fossil one, the dorsal view of the skull. Fractocephalus nasi, we described in 2004 in the desert area today. This area from Venezuela is absolutely a desert, xerophyte vegetation, no river, and is in the north part of the Cordillera La Costa, coastal cordilleras. Okay? In addition to these pimelodids of Fractocephalus and other pimelodids in Brachyplatystoma that I showed a picture from the Tatacoa Desert, remember? Brachyplatystoma is the skull in different view, dorsal, ventral, lateral view, and compared with the modern ones, Fractocephalus, especially Fractocephalus bayardi, that exists, has a wide distribution into the hydrographic system of the Amazon River, including the Orinoco River and the Amazon River, Negro, etc. And also we recovered from Castillete in the desert of the Peninsula Guajira in Colombia. Weberen apparatus is the first 5 modified vertebrate in this catfish. The Proto-Amazon exists in all area or influence or all area. Continue with the siluriform from a typical South American siluriform. Is here the thorny catfish, is a doradids. The preservation from the Urumaco Formation is not the best, but we can identify different skull, bones, relationships, and we can identify almost genus, and we try to identify species with the different dozen of the specimens that we collect, especially Doras, Pseudodoras, Platydoras is the more common genus from the Urumaco Formation. Again, closely related with the Proto-Amazon fauna. This environment of first world includes lowland Amazonia. It's a Pacus, also very well recognized by thousands of isolated teeth that we recover in our area, especially from the Urumaco. Continuing with this triangle, Colombia, Venezuela, we can look the Miocene, La Victoria, Villavieja assemblage, vertebrate assemblage. Again, large mammals, terrestrial mammals, freshwater mammals, crocodiles, turtle, of course, fish like lungfish, arapaima, or pirarucu in this area. Typical Amazon fish, okay, from the Tatacoa Desert. The last expedition was in 2019. We recovered absolutely a very high diversity and quantity of fossil fish remain in this desert associated just from the Proto-Amazon fauna again. This triangle is a mega wetland also. And in this picture, you can show you a school from lungfish, different view, dorsal, lateral, and anterior with associated jaw. Isolated jaw of this Lepidopsidium, a lungfish. Postcranial element like a Weberian apparatus from the Pimelodids, Fractocephalus also, ethmoids, or opercle and large scale of arapaimids. It's a tongue fish. Continue with arapaimids, some infraorbital bones. I illustrate here only the diagnostic bones to recognize it, family, genus, and different species. Okay. Between the cichlids, different lower jaw, two lower jaw is a dentary bone. Also, dog tooth here, and colosoma is a cachama, serrasalmids, upper and lower jaw, and a lot also of isolated teeth. It's very, very abundant in the Tatacoa Desert. Pimelodid here represented by a fragment of a skull is a Fractocephala 1, is Pimelodid, is a supraoccipital, pectoral girdle, dorsal and pectoral spines. Loricarids is represented also by dorsal and pectoral spines, and a sectional peduncle with ray and scale well preserved. It's rare. It's very scarce to find a fossil fish in this condition. Okay. Between the siluriform, we talked. I show you from the Urumaco, thorny catfish is Doradids. Is hundreds of bones. It's really, it's very rich, very abundant and diverse. Included Doras, Pseudodoras, Platydoras, Rhinodoras. all ones is very well represented in the modern fish fauna from the Amazon hydrographic system. Continue also with our mega wetland, the Miocene Solimoid Formation in Brazil. I don't need to talk more about this one because it's plenty in vertebrates, associated fauna, including mammals, reptiles, and also fish. For this example, I show also the colosoma is cachama. Look, this opercle, the skull is 10 centimeters. And the lower jaw here, a broken dentary, is just for the 10 centimeters. It's a very large specimen. The second specimens of the or species of the Fractocephalus is the red tail pimeloidid. Catfish is a dorsal view of Fractocephalus. Acheronatus we described in 2008. It's really a large catfish from the Amazon. Continue to the south of the mega wetland. It's very large mega wetland. We thought from the Caribbean in Colombia, Guajira, from the Caribbean in the Urumaco Formation in Venezuela, from the Western Amazon Solimoid Formation in Brazil, and now we talk in Peru, the continuity of this wetland is the Iquitos area. Again, high diversity of vertebrate fauna, including mammals, reptiles, and fish. And especially this picture is to show you the exclusive or permanent freshwater fish, cachama, pacus, arapaima, piranhas. And this one is a plagiocyon, it's a freshwater fish today, but here is the marine derived fish from cyanide, from marine cyanide in the area, of course, Potamotrigon, a freshwater race. The fossil here represent by teeth of cachama, pacus, piranhas, dogtooth, etc. And sectionally, otolith is ear bones from Iquitos. It's sectionally because in marine deposit it's very common, but not in freshwater. It's very difficult. It's the first record from otolith. So we can see here otolith from marine catfish, arids. The occurrence, the records in the Pebas Formation represent a derived marine species. Also from the croakers or cyanide, all these otolith is from cyanide, very known Pogonias, Cyanops, Umbrina, like in marine modern fauna. And plagiocyon is a derived one. Some molecular story represent the relationship between the freshwater cyanide, especially from the genus Pachyrus, Pachypop, sorry, and plagiocyon. The important thing to show you this picture is we provide and test together with the molecular clock the records, the fossil, because we can match the fossil record with the molecular ones. It's very important for all to understand the evolutionary trends of the different marine or marine derived fish in the Amazon or Paleo-Amazon or Paleo-Orinoco or Paleo-Magdalena. Okay. In fact, we agree also. We agree because the middle Miocene is our record from the Plagiocene in marine area, and now the middle to late Miocene, the record of Plagiocene in freshwater environment. Exist diverse examples about the marine derived species. Stingray, anchovies, herring. I talk now about the Plagiocene. Here is a freshwater croaker and puffer fish that I show ahead some examples about the marine derivatives. Marine originary species that invaded the freshwater environment remain like a permanent freshwater fish. Well, the hydrographic system in the Amazon is very complex. It's really very complex. This complex is associated with different orogenic, tectonic, and climatic change, including marine incursion that we talked today about that. But if we continue to the south in the Paraná fluvial system in the north of Argentina, also we can find the similar fish fossil fauna, like fossil siluriform or freshwater catfish, pimelodite, doradite, and also colosoma or associated with piranha, the famous mega piranha described from this area. When I talked about the complex of the hydrographic system in the Amazon and to follow the different orogenic tectonic change, we can understand along the geochronological sequence the difference of the connection or interconnection of the different affluent, effluent, or main central channel associated with the process to the Andes rise, especially from the central and eastern Cordillera in Colombia, and the structural arch in the Amazon area, Iquitos, Purus, Guarupá. And it's easy to understand the separated between the Western Amazon and Solimões for one side, and for other, here in the Amazon or the Essequibo Rio Branco River. And again, along the time, we can see the connections to form or the changing course of the Orinoco River, the Magdalena River, the Maracaibo Lake system, and the Amazon. Okay? During exactly late Miocene. When we talk about mega wetland from the Caribbean to the south, the north of Argentina, and the occurrence of large diversity of vertebrate fauna, we can associate it also with some example. This one is Stupendemis geographicus. It's a large world turtle, freshwater turtle in South America. Okay. Record from the Acre in the Solimões, La Venta in Colombia, Villavieja, and the Urumaco. It's a large connection on this mega wetland by the central or the principal channel. Okay. Also in this picture is Purosaurus. It's a very large crocodile Purosaurus. Also present in Urumaco, in La Venta, and in Acre. And of course, Fractocephalus, a pimelodite catfish. It's very common. Or doradites or loricarids is really very common. Other example of this mega wetland is represented here in this picture is from using the Mata-Mata turtle. It's Kelus lewisi, Kelus. And the Caimanid also to talk about the Acre, Paleorinoco, or Pega lake system. It's very interesting, it's very complex. And again, when we talk about the connection, interconnection, or isolation of this hydrographic system, we can talk to understand the dam formed by the Iquitos, Carupá, Purus, and Gurupá structural arc that impeded the flux. Is like a dam in this main channel. This dam, of course, is superated with the rise of the Andes. Okay? It's a subduction that formed here, represented here, by the Pevas Lake or Pevas area, and the erosion and transport of the sediment to infill this subduction or this basin, and to complete the connection of the transcontinental Amazon River. This transcontinental Amazon River reached the Atlantic side around 10 million years. Associated with this new freshwater or new change in the Orinoco, Essequibo, Amazon, and even the Magdalena River, we show in these two pictures marine incursion. It is absolutely very important. Marine incursion in different pools, different age, different area of influence, and because the record tests specifically the occurrence of mollusks, bivalves, like Crassostrea, is the contribution of Professor Pierre Oliver, and crustacean decapods, forams, foraminifera, ostracods, bryozoan, and palynology, different mangrove, marine mangrove in this area. We remember that the tectonic activity in this area was very intense. I showed the consequence of this one. But the marine incursion is very important topic to study, to research, to understand of this dynamic in the western part in South America, associated just with, in our case, just by derived marine species that inhabit today, like a freshwater species like a Plagiosium, Pachypods, drum or croaker fish, or puffer fish, or ray like Potamotrigon, etc., etc. It's a nice history to show you. And of course, the Trans-Amazonic River, the Amazon River, the onset 10 million years ago, products of the lixiviation of the Andes and cratonic sediments. Okay? Well, for now, I talk about the freshwater or the inland environment in South America. But South America implies epimarginal sea also, especially from carbonated area. And the consequence in this picture to show you the tectonic activity from the Caribbean plate and the South American plate moved east to western, and in contrast, the Cocos and Nazca plate from the western to the eastern, and originated in large view the Lesser and Greater Antilles, the volcanic island in this area, and the uplift of the Panamanian Isthmus. In the consequence in the South America is the Andean rise, especially the Oriental Cordillera from Colombia and the Cordillera da Costa in Venezuela. It's a very dynamic. This dynamic produce different paleobiogeographic, alter the oceanographic pattern during the early Miocene because produce the isolation from the Atlantic and the Pacific Ocean, especially during the Central America Seaway, a wide connection between the Atlantic and between the Pacific Ocean, the mixture of water mass, the low temperature, the increase in silicic nutrient to produce outwelling, for example, and the complete isolation of the Atlantic and Pacific with the uplift of the Panamanian Isthmus around 3.5 million of years. Of course, today we maintain open the discussion about the complete closure of the Panamanian Isthmus. The discussion is open in different scenarios, but the more plausible close is around 4.7 million years ago. Consequence, the burn of the Caribbean Sea by this isolation. Consequence, the isolation, Atlantic and Pacific, Central America Seaway, the land bridge between North and South America, and the pattern of the oceanographic current, including the distribution of high temperature in this area. When I talk about the change course of the Amazon River, it's important to see what happened in the coast. And this picture shows the Pirabas formation in the Atlantic. It's the equatorial platform in North Brazil. Okay? The Piraba formation is located very close to the Amazon River Delta, and is basically siliciclast mixture with carbonated. The framework of this carbonated is coralline algae, bryozoan, mollusks, echinoids, crustacean, fish, and also mammal, sirenids, dugongids. Of course, including fish. This one is catfish, is catorops. Catorops today is a species that inhabits a very shallow water. Catorops included from French Guiana also. This is the catorops. It's very easy to recognize it, and it's very important to understand the relevance like a environment indicator. And if we know the fossil catfish of the family Arids, we can understand or we can explore the chronostratigraphic relationships, and you can saw ahead the relevance of this stage between the late Miocene, because in this moment is the plenty turnover of the fauna, associated, of course, with the climatic change that I talked, hydrographic change, oceanographic changes. I talk again. From Piraba formation, we recover just in one locality. Our crops is 10 centimeters planted with thousands of otoliths fish, especially typical tropical Caribbean fish today, Lepophyrium, Carapus, Midipristis, Apogon, Thalassophreni, Batragoides, and Cyanide, drum and croaker. A lot of drum and croaker. So this one is Echetulus. Echetulus is associated with the Echetus, is a cardinal fish that live today in the Caribbean in coral area, in coral reef. But in this time, we don't have coral reef, but have a lot of coralline algae. This is very important, included for the petroleum exploration. It's not a coral reef, it's a coralline algae. Okay, with cyanide, exploring the chronostratigraphic distribution is basically the same situation. It's a turnover in the late Miocene. And again, different species, and we can talk about the Amphi-American distribution, usually with the epimarginal sea. It's a carbonated epimarginal sea. Amphi-American because we can find in both sides of South America. Typical Echetulus, Cerritus, Larimus, Ophiosum, and Stellifer, including some from the Caribbean island. And we agree with the Woodring hypothesis or thesis talking about the Gatunian Caribbean province. No? Other species that are very important for us is lanternfish. Lanternfish inhabit around 1,000 to 2,000 meters, but have daily migration to the surface, and is associated just with outwelling phenomena in the coastal area. And with outwelling phenomena in the Caribbean is very rare, absolutely in the Margarita Island in Venezuela and Guajira Peninsula in Colombia today. It's not as stronger like the Benguela Gulf or from the Pacific side of Peru, but it's weather, a very low temperature of this world mass. And lanternfish, of course, is absolutely a nice fossil guide to interpret the paleoceanographic changes in this area, a consequence of the Central America seaways dominated by the Pacific water mass. And also we can use the geochronological sequence, or we can explore in the sequence. It is the black one, Myctophyte, to use like biozones. If we're tracking the fossil estuarine, we need to understand very well the stratigraphic sequence, especially the phases, lithology, because we can interpret different environments. In between this environment, we can find a school of catfish, Islamic catfish, like Arid. We need to understand bias and mistake because the preservation of the bone is hydroxyapatita, the otolith is aragonite, and teeth is a fluorapatite. And you can find problems by genesis and can separate it, describe it. One species using the skull and another species using the otolith, but the real is the one. It's just one species. When we use the tomography, we can corroborate it, and it's very useful to understand the paleontology mistake or bias can be introduced is we work just with isolated specimen or fragment of the bone. Marine catfish show also the same mosaic of distribution. is very useful to understand demersal fish, especially the porcupine fish, sorry. The preservation of the bone is scarce, especially we recovered its upper and lower jaw from Venezuela, Panama, Trinidad, Cuba, and also Dominican Republic. It's very few records, but it's very important because it's very regional, very localized during the Atlantic Pacific seaway connections. All of them is very important to recognize it these seaways, including tetradontids. These tetradontids, you can see a large wild distribution and some preference, for example, Lagocephalo labiatus and the Atlantic side distribution, other Indo-Pacific distribution, and the marine-derived Colomesus in the Amazon hydrographic system. Molecular biology is very useful to understand the evolutionary trend, of course, but we need to calibrate the age, the molecular clock to understand this radiation around or area. Here, I show the tetradontid and diodontid neogene is more or less in the Miocene. Okay, we find in the early Miocene. Other specimens is moray, Gymnotaurus from Gatun Formation. Also, is the first record of moray in all tropical America. It's under this crisis. Again and again, we need to calibrate the molecular clock to understand this evolutionary trend based in the fossil record. Also, Lutjanids is a snapper. Pelagic fish like Mokaira or billfish is this specimen comes from the Gatun Formation in Panama. You saw in this map the Amphi-American distribution, also Mediterranean on the Atlantic, and also the Indian Pacific Ocean. The Amphi-American, again, is a large groupers, is Epinephelus from both sides of the Atlantic, in Africa, South America, and Pacific coast of South America, other from the Pacific, and the equatorial carbonate platform that just exists because don't exist the Amazon Delta at the same time. And the erosion of the cratonic sediments in the flows to the ocean, because it's a very large deposit of the Piraba Formation, is the carbonated area that continued in the ocean. The first example is a disaster, is a mine company in Brazil, and in few days reached the coast. You can see the turbulence of the water and the collapse of the carbonated or organisms that produce carbonated that emit. Okay. Bon, we can prove this because we use geochemistry and petrography in the carbonated rock to understand that in the littoral area is under the influence of the coast, and outside is planting in carbonated producers, like in the Amazon, Pará, Maranhão, the Potiguar Basin in the ocean. We here show the petroleum drill well, just to show the influence of the sea level rise, drops, change exactly all the area, and finally the temperature by the cyclonic and anticyclonic distribution of the temperature of the ocean. Of course, a hard influence in the fish fauna assemblage. And to finish, it's fine, to show you the dynamic from the early Miocene, middle Miocene, late Miocene, Pliocene. And finally, our theme of discussion, the macroevolutionary context influenced by the Panamanian isthmus uplift, the Atlantic Pacific isolation, the Andean rise, the hydrographic system change, a global sea level change, the marine inland incursion, the collapse of the equatorial carbonated platform, and the fauna origination, extinction, and turnover. Thank you so much.
Muito obrigado. I just forgot to say that Orangel was coming from the University Fluminense in Rio, but you probably had noticed that. Okay, so is there a first question? Nobody? Nobody has a question? So I have a question. So you have told that there were scattered outcrops especially in the Amazon. So is there by chance a way to have a better picture of all the sequence between the Paleocene and right now, or the column? Is there are there perspectives to get information from the same area or projects or something like that to gather the information?
Yes, this is a big question because we need a lot of contribution, field trips, identify the different sections in the Western Amazon. I talk about the difficult to access by the forest and the logistic support to understand this area. For now, the most paleontological survey or research is a traditional of paleontology. It's a systematic tradition, but we need, of course, partnership with geology, stratigraphers, palynologists to construct a very accurate information about the stratigraphic section, because most of the collection was in boats around the river, taking the big one, the very well preserved Purosaurus, without a stratigraphic section very accurate. I suggest, of course, this is the idea of this meeting, to invite you, different groups, to explore the Western Amazon in South America, all South America, because it's very important. It's a very few, we know very few outcrop, very few material. It's amazing opportunity with the modern technology. Now we can use a micro CT scan, now we can compare with genetical research. Now we can recognize it, different nano, micro, and large specimens. But stratigraphy, sedimentology is very important, especially from age. And geochemistry, of course, uranium, thorium, isotopes for very accurate age.
Okay, thank you.
Il y a des questions.
Perhaps. Okay.
Okay, so here we see really a story about the Amazon, that part of the world where it originates. But further south, what is happening in the Cerrado and places like that? Is it kind of the same time scales, same patterns, same time scale?
Yeah, from Cerrado. Yes,
Going
just
south
wait,
and Atlantic and so on.
yeah.
Just wait for a moment. So there is a question about the situation more to the south in South America, if it's the same situation as in the Amazon basin and the Caribbean, or if it's contrasted.
No, it is contrasted. It's contrasted. But I show that all the research is concentrated in the eastern part of the South America. Cerrado is not included, unfortunately.
So no data.
No data, no
Okay.
data, no data.
Thanks.
No. Mostly from this age, no data, no data. Yes. Thank you.
We have now a question from Aldo Benitez, who can unmute his speaker and ask him directly.
We do it.
No, you
Do
can
it.
do
Do
it.
it. Okay.
Aldo?
Don't be shy, Aldo.
Yeah, hello, Oliver, Piero, hello, Orangel. Thanks for the presentation. I wanted to ask you, Orangel, is there a way of quantifying the diversity interchange between the Western Amazonian localities that we have? Because the Amazon complex is really wide and there is a strong interchange of the species happening nowadays. But what about the fossil record? Is there a way that this can be quantified, or do you plan to do so in the future?
Yes, thank you. The quantification is very complicated because we need to know the stratigraphic detail. The sample is the same. In the middle channel, you can find Stupendemic, for example, or Purosaurus, or Fractocephalus. But it's just in the border on the small tributary that you can find loricarids, or in the inundation plain, you can find colosoma like cachama or piranha. It's very difficult in the field to establish what area corresponds to the main channel or the tributary or the inundation. For this reason, the question about the geology, sedimentology, stratigraphy is very important, because we can put all the fossil in the same box. We need to recognize the different areas in the field, personally, and explore, and to use the quantitative approach to understand this diversity and the relationship with the one group or another group. I don't know, this is the question. But in the future, of course, yes. This is what was the problem when we work just from the museum, old museum collection. That, do you know the field? It's very important for geologists or paleontologists. Go to the field and associate your sample with the paleo-environment and figure facies and lithologies.
Okay. Is there another question? So, Aldo, you're welcome coming here whenever you want.
So there's a second question from Zoom. By Marcelo. Marcelo Sanchez, you can unmute your speaker.
Can you hear me?
Yeah, we can hear you.
Okay. Thanks, Orangel, for the overview talk. Much appreciated. You have worked on zooarchaeology in the Amazon. Do you know of any signs of any kind of aquaculture or managing of fish populations from pre-Columbian times?
Thank you, Marcelo. Nice to hear you. Okay. Yes, we work also so archaeology. It's a pre-Columbian site in Brazil. It's around 2,000 of sites. But it's pre-Indian. The name is Sambaquis, the Sambaqueiro. It's just for fishing, no aquaculture. We recover tools and different sharp teeth bone, for example, to sharp teeth and bones, vertebrate using for construction, but not for aquaculture. It's just wildlife fishery. It's not aquaculture.
Thank you. Thank you.
Is there any question from paleontologists? Okay, so I got one more, if I may. So you have showed lungfish from Tatacoa.
Yes. Yes.
Which size are there? Is there a disparity of sizes, or all of them are large or small? I don't know.
Lungfish is similar to the lungfish today.
Similar.
It's similar. It's not so large or so small. It's very similar. It's amazing because the large fossil one that we recovered from the Western Amazon, the Fractocephalus. The school represent the retrocalculation is around 2 meters. 2 meters of Fractocephalus is a very large specimen, but it's not the large one. I saw the pectoral spine that you showed me. It's really, really, really very large. But usually it's very small. About marine fishes using the otolith, I thought that it's a myth that the fossil fauna are bigger than one. It's a myth. I never find snapper, grouper, croakers, larger than the fish today. It's really very small. Very small. Base in 31 formation examined. It's a lot of material.
Thank you. I think we're done. So thank you very much, Orangel, and thank you very much to the organizing committee for having made it very smooth. Thank you very much.